Good day once again, ladies and gentlemen, and we meet yet again. As promised, I wanted to just finish up on the electrochemistry, particularly the electrolytic cell. And so, what I wanted to do in finishing this part up is just to do typical exam questions. So, what I'm going to do is just pick up two question papers that on these sections, and we are going to tackle them together. Okay. So if you haven't subscribed, please just do the right thing. And by the way, please don't be afraid to just hit that like button if you like this video. And obviously, if you have got any questions, just check the comment section and just ask any questions that you may want. I'll typically try to answer as quickly as I possibly can. All right, so let's get into it. Okay, right. So we learned about the electrochemical cell, okay, or rather the electrolytic cell previously. So I'm just going to quickly dive into the questions. All right, so I'm picking up the 2019 question paper. All right, and they've got a question there. They've got two cells. Okay, so there's our question. They say the diagram below represents the two electrochemical cells. PQ, X and Y are carbon electrodes. So there we are. We've got carbon electrodes that are given there. Remember in our previous video, we did say that they do use graphite at times. Okay, but they may use any other type of metal for that matter. But graphite is a semiconductor, right? So they say when the cell is functioning, the mass of electrode X increases. Okay, so they are trying to tell us something very important there. Now let's have a look at it quickly, ladies and gents. So I'm just going to put the question paper this side and try to answer the questions together with you. Okay, right. Now, first of all, let's have a look at those two parts. So let's look at cell A. So cell A has got a positive side. Now remember that the positive side, it's the longer side. So meaning that it automatically makes that part P to be positively charged, isn't it? Okay, and then obviously electrode Q would therefore be negatively charged, isn't it? Okay, so now they've given us sodium chloride. So what would happen typically with sodium chloride is that you would have sodium chloride break down like that, and it dissociates, okay, into sodium plus and Cl minus ions. So those are the two ions that you have, sodium cation ions and chloride anions, right? So obviously we did say that the cation ions would be attracted to the negative side of the cell. Okay, now they say to us, let's see the questions that follow. They say, what type of electrochemical cell, galvanic or electrolytic, is illustrated above? Of course, we do know by now that this would be the electrolytic cell. Remember that the galvanic cell is the one that converts chemical energy into electrical energy. Here, we've got a cell that is driving a reaction as a non-spontaneous reaction, and therefore this would be the electrolytic cell. Okay, now secondly, they ask us the question. They say write down the half reaction that takes place at electrode Q. Now let's look at it typically. So the electrode at electrode Q, remember we said it's negatively charged, isn't it? So as a result, because it's negatively charged, it would tend to attract those sodium ions. So the reaction that takes place at electrode Q, okay, at electrode Q, you would have the sodium ions being attracted there. Okay, so sodium plus would therefore receive electrons. So sodium would receive electrons, and therefore it would turn into sodium. Okay, sodium plus sodium ions. Okay, so the reaction that takes place there is actually reduction. Okay, the gain of electrons. Okay, and then the next one, they say to you write down okay, so we've gone through that one, 9.2. They say the product formed in the two cells are compared. Okay, now before I answer that question, if you don't mind, I would like to just quickly analyze what happens in this reaction, and I think it would make it easier for us to answer. So in electrode or cell A, by the way, okay, I know at electrode P this would be positively charged, and so the reaction that takes place there, remember we said there's sodium and chloride, right? So because this guy would be positively charged, I know it would attract the N ions, the chloride ions, okay? And so as a result, you'd have 2Cl minus. Now, I'm sure someone is frantic out there asking, but how do you know it's going to be 2Cl minus? As I did say, ladies and gents, all you just simply do is just go to your to the back of your question paper. You've got that reaction there, and it doesn't matter which cell you take, okay, which half cell standard reduction potentials table you take, okay. I know some people may want to insist, now take the B, take the A, it doesn't really matter, it's the same thing, right? So there it is, 2Cl minus over there plus 2 electrons giving you 2Cl minus, okay, rather Cl2 here plus 2 electrons giving you 2Cl minus. So in this case, because we started with Cl minus, that's why I would flip this around, okay? So we'd start on this side going to that side. So as a result, the process that's taking place there, 2Cl minus, is becoming Cl2, right? By giving away 2 electrons. That's what's happening at P. Okay, let me open that up again. All right, so that is what's happening at P. And at electrode Q, as I did say, that's the reaction that's taking place. I know that sodium plus is now receiving an electron, and therefore becoming sodium. Okay, now so going back to that question, okay, so now they are simply saying to us, okay, we now need to they said the product formed in the two cells, we are now going to compare them, right? Now this was for cell A, okay. Now let's go to cell B. And by the way, for cell B, can you see that they didn't indicate? They told me it's a DC source, it's a battery. And by the way, it has to be a DC source because you have to maintain that polarity. So you can imagine if you had an AC source that would kind of alternate all the time, you wouldn't have, because you'd keep reversing, forming a product and then reversing it again. So you just need to have a DC source so as to maintain constant polarity on each side. So so this would be cell A, okay, and what would happen at cell B? Okay, so this would be cell A, and cell B. Now what's going to happen at cell B? Okay, now at cell B, now please, I want you to look at it. We've got copper chloride. I think I've covered this in the previous video. If you haven't checked it out, you'll see it there. So typically, what do I have? I have copper chloride, but when it breaks down, what does it become? It becomes copper 2 plus, and it becomes, you have 2Cl minus ions, right? You've got chloride ions as well as copper ions there. So what would happen? On the positive side, now, they had given us information there. They said on cell B, the mass of electrode X increases. What are they in fact trying to tell us by the mass increasing? All right, so it would mean that this is where we are now forming the copper, isn't it? This is the side that would be undergoing reduction, where we are forming the copper. So in this case, it means at X. Now, please, I want you to note, it means copper 2 plus ions at electrode X. Copper 2 plus ions would now be reduced, receive electrons, and therefore become copper. So as a result, because you're forming copper over there, it would tend to be heavier, and in this case it gains mass. And then it means that electrode Y, once again, what happens there? Means that those are the chloride ions. So therefore, at electrode Y, it would be exactly the same as electrode P. So 2Cl minus would now become chlorine rather, Cl2, which is a gas, by simply undergoing oxidation. So that's where oxidation would take place. So in a sense, this already tells you that electrode X, in order for it to attract the copper 2+ ions, it tells you that electrode X must be negatively charged. And remember, in an electrolytic cell, we said the negatively charged electrode, right? Remember, in a negatively charged electrode, that would be, in this case, our cathode. Okay, so it means that X would be our cathode, but I mean it makes sense. Reduction takes place there, and then it means that Y would be your anode, obviously, because oxidation, the loss of electron, takes place over there. Now let's answer quickly the questions, and you'll see how easy this is now after we've done that analysis, right? So we're simply saying, they say write down the substance that is produced in both cells. All right, it's easy now to compare. Okay. Yeah, we did answer 9.2, right? We did say write down the half reaction that takes place at electrode Q. So there it is. Now we are comparing. They say name the one substance that is produced in both cells. So definitely in both cells, what are you producing? You are going to produce chlorine in both of them over there. Can you see? So in this case, that would be chlorine that would be produced. They say write down the letters of the two electrodes where this product is formed. Choose P, Q, X, and Y. So where are we forming chlorine? Note, in cell A, we are forming it at P. In cell B, we are forming it at Y. So your answer there would be at P and Y. Okay? And then they say, is electrode X the cathode or the anode? All right, so we've already done that there. So electrode X would be your cathode. Why? In this case, because reduction takes place over there, right? And then finally, they say give a reason for the answer. Of course, I've just mentioned it there, because reduction takes place. All right, and say, and the last one, they say write down the net or the overall reaction that takes place in cell B. Okay, so now let's take cell B. We are simply saying, what would be the net cell reaction that takes place? So I'm taking both cells. Okay, let me just rewrite those reactions over there. So that's copper 2+ plus 2 electrons, and I make sure this is copper, and 2Cl minus, that would be Cl2, but I've got 2 electrons over there. And the net cell reaction, what would I have? Please always make sure that the number of electrons, okay, that are received equal to the number of electrons given. If not, you have to make sure that you make adjustments to your reaction. Okay, so those are equal, so I can cancel them out, and then take everything that's on the left hand side. Okay, copper 2+ of each equation plus 2Cl minus. Okay, and what would that give me? It would give me copper, the solid, okay, and also chlorine, the gas. Okay, so this would be my net cell reaction. Of course, these two would be in aqueous form. Okay, both of them would be in aqueous form. So that would be the net cell reaction that is formed in that cell. You can, or you are allowed, you can actually write it as it was before you had copper chloride. Okay, so that's CuCl2. Okay, so the net cell reaction would be copper chloride, giving you copper plus NaCl2. Okay, so that would again be your net cell reaction. Okay, so that's the one question paper done. Okay, and you would have gotten yourself full marks on that. All right, let's take the second question paper. All right, so I'm taking that from, again, DBE. That's question 9 from 2018. Okay, I chose these ones because they represent two different types of reactions. Okay, so they give us the diagram below shows that an electrolytic cell used to electroplate an iron rod. So in this particular case, this is electroplating, unlike the previous one where it was electrolysis, right? So they are electroplating this iron rod with copper. All right, so you would have iron and you want to actually have copper all around it. Okay, they say solution X is made out of an unknown nitrate. If you watched my previous video, again, it would actually make sense why they would use that solution there. Obviously because it is able to conduct electricity, right? Now let's look at the first question. They say, okay, so I'm gonna just put a question paper over there. I hope you can see it quite clearly. Okay, right, now they say to us solution X. Now first of all, before we actually start answering the question, let's see what happens over there. So this iron rod, remember, I want to make sure that this iron rod, okay, is plated with copper. All right, so in order for it to be plated with copper, I need to make sure that now this becomes my cathode. Okay, so in this case, it has to be my cathode because that's where I want to a reduction to take place, isn't it? I want those copper 2+ ions to kind of be attracted to the side. So you can imagine what polarity should it have. Of course, this guy should be negatively charged, isn't it? So in this case, in order for it to be negatively charged, that would be my cathode under the galvanic cell. Okay, so obviously this one would be positively charged. That would be our anode in this particular case. All right, so now let's answer the questions quickly. Right, now they say solution X, solutions such as X are always used in the electrochemical cells. Okay, write down the general term, okay, used to describe these solutions. Okay, so how then do we describe the solutions? Okay, we know those are simply called electrolytes. Please remember that, ladies and gents, right? We usually call those solutions electrolytes. Okay, and what are electrolytes used for? Remember that they are able to conduct electricity. Okay, those are solutions that are able to conduct electricity. And that's the next question. What is the function of these solutions? Right, in order to make sure that there is continuous electrical energy that is in the cell, right? So they conduct electricity. They say write down the formula of solution X. Now, remember what I said in the previous video. If you haven't watched it, please just make sure that you watch the previous video on the electrolytic cell. All right, you'll see what I meant there. Now, what are we trying to actually form here? We are trying to actually coat this guy with copper. So it means this solution must have copper ions in it. Okay, so as a result, now please, I want you to note, ladies and gents, because we are talking about copper, it should actually, they said to you, write down the formula of it. Now remember that copper is copper 2+, right? And nitrates, it's actually just NO3 minus, right? So if I'm going to write this, this should be, remember, it's got an oxidation number of 2+, and this one only 1 minus. So in this case, you need 2 of those. It means this guy has got 2 arms in a sense, right? So those 2 arms can hold on to 2 of those. So your it should be copper nitrate, but it's able to hold 2 of those nitrates over there. Okay, so that would be the solution. That would be our answer for 9.2. Okay, right, now let's go to the next one. They say which electrode, A or the iron rod, is the negative electrode, and give a reason for your answer. Now we've already kind of answered that, isn't it? So we said in this case it would mean that the negative electrode would be our iron rod, because that's where we are trying to coat it with copper. We want those copper 2+ ions to be attracted to it, and as a result it would be it would be the iron rod. Okay, and why? Because reduction has to take place there, right? So this is the reaction that we want to take place. We want it to obviously, because it's got those electrons, so the copper 2+ ions would be attracted to the electrons, and in this case undergo reduction and therefore form copper over there. So this guy would be covered with copper. All right, and then they also say so the reason there is that obviously we want reduction to take place over there. Okay, so they say write down the half reaction that takes place at electrode A, right? So at electrode A, it would exactly be the opposite of this reaction. It would be oxidation that's taking place. So copper would be breaking down. This would be pure copper over here, right? And it would now break down, okay, undergo oxidation, and now become, right, copper 2+. Remember, at the same rate that you are forming copper 2+, you are also reducing it there, and in this case you would form copper in the iron rod. Okay, I hope, ladies and gents, that still makes sense. Okay, and then they say write down the half reaction. Okay, we've already answered that. Okay, now for the last two questions, they say electrode A is now replaced with a silver rod without making any changes to the cell. Okay, write down, or rather after a while, two metallic ions are found to be present in the solution. Okay, right, now they say name the two metallic ions that would be formed. Of course, you still have your copper ions over there, but you would also have your silver ions over there. So those are the two ions that would be formed. Now they say to you, and I always like these questions, they're quite easy to answer. You'll see that in just a while. They say refer to the relative strength of oxidizing agent to explain which one of the two ions will preferably be involved in the plating process. Now, ladies and gents, remember, what did they say? The strength of oxidizing agent. Okay, now all you simply do to look at the strength of oxidizing agent, okay, all you do, go to your standard potential table, look at the side that says oxidizing ability. Now remember, which are the two that we have? We've got copper, all right, 2+, and also we've got silver. Now what I'm simply going to do is I'm going to search there. All right, now that's copper 2+, that's 0.34. Can you see it there? Okay, and then I also have silver, which has 0.80. Okay, so what does that say to me? Okay, it means that copper has got a higher strength. Not copper, rather, silver has got a higher oxidizing ability. It means it has a higher strength, all right, of acting as an oxidizing agent. All right, so silver in this case would have a higher strength as oxidizing agent. So as a result, that is why it means that you'd find your cell actually covered with silver or plated with silver. Why? Because it's got a higher strength as oxidizing agent. Okay, now they said refer to the relative strengths, okay, of oxidizing agent. Which one of the two ions will preferably be involved in the plating? definitely it will be silver, right? So it means that silver would easily tend to undergo that reduction process because it's got a higher oxidizing ability, or it's a higher it's got a higher strength as a reducing agent, right? So it would tend to undergo reduction quite easily. Okay, so in this case, it would be silver. And obviously you'd explain that it's got a higher strength as a reducing agent. Okay, so ladies and gents, I think this typically just solves it in terms of that question. Okay, I know that I didn't do quite a lot of writing, but I went through this question with you so that you could understand how to typically just answer these questions. Okay, right. And by the way, if you've got questions, please go ahead and just throw them onto the comment section. And by the way, just also make sure that you subscribe if you haven't, and just give the video a thumbs up if you liked it. Otherwise, I'll see you guys next time. All right, and hopefully you keep studying. Okay, see you guys next time. Sharp, sharp.